video, we're going to talk about how to use the LockDown browser spreadsheet app to answer a question with binomial probability, because the binom.dist function in Excel does not seem to be working. So for example, here's a question where we've been asked to construct the binomial distribution with exact probabilities for K with 5 trials. So K is representing the number of successes out of the 5 trials that are possible, and then we're supposed to come up with the exact probability or the probability of each exact number of successes. And the quickest way to do that is with the binom.dist function in Excel. But even though, and what I'm talking about is using this right here, but even though that would be convenient, there is another way to do this. Since the binom.dist, this function right here, binom.dist, does not seem to work, at least at the time of this recording, in the LockDown spreadsheet. So most things do behave pretty close, like exactly like Excel, but I have found a couple of differences. This is one of them. So what we're going to do instead is we're going to use the actual binomial formula, which is right here. Okay, so calculate probabilities of an exact number of successes, right? So we're going to use the formula. But even though this looks maybe a little complex, especially with this first part of it here, that first part of it, the n factorial over n minus x quantity factorial over times x factorial, all that actually simplifies to the combinations formula, and there is a function in Excel for that. So it's not going to be too tedious to use the formula, and down here you can see the notation with the combinations in place of all that extra, instead of doing the combinations formula by hand, we can use the combinations formula in Excel. So here's what we're going to do. Okay, so we're going to do it with this question right here, right? So for the number of successes, we'll call that K. You can see we're going from 1 up to 5. And then the probability of exactly that certain number of successes, we can program it once in the first cell and then copy it down. So we're going to do the combine function, COMBIN. We're going to put in the number of trials. Even though it says K comma N, I tested it. It actually works like it should, the same way it works in Excel, which is actually reverse N comma K. So I'm going to put in my N first, which is 5, the number of trials, and then K is, for this row, is 0. But I'm going to click on the cell so I can make this a relative reference, and that will copy down to all the other rows relatively. Now I'm going to multiply that. Okay, so I'm using this formula here. So I just did the combinations part right there. Now I'm going to multiply that times the probability of success to the power of that many successes. So that is, in this problem, the probability of success, P, is given as 0.718. So this is the probability of success in each trial. So I'm going to put 0.718 to the power, and then I'm going to click again on the cell containing K for that row and leave it a relative reference. Next, I'm going to multiply that. I'm moving on. I just did the P to the power of X part in the formula here. Now I'm going to do Q to the power of N minus X. So the remaining trials that were not successes, N minus X trials, would be the probability of a failure to the power of N minus X. So Q is P, 1 minus P. It says that up here also, if you forgot. So P is the probability of success in each trial. Q, make this a little bigger for us if I can. No, I guess I can't for whatever reason. Q equals 1 minus P, the probability of failure in each trial. So now I'm going to do the Q, which is 1 minus P. And remember, P is, for this problem, was 0.718. So I'm going to, am I missing that here? Something's off with this. Let me just go back a step because that looks weird. It should say times 0.718 to the power of x. Okay, that looks right now. Okay, that's what it's supposed to do. Now I'm going on to q to the power of n minus x. So q is 1 minus p, 1 minus 0.718, quantity. Okay, there's the q part. It's the whole quantity. I have it in parentheses after the times symbol. And then I'm going to raise that to the power of n minus x. So n minus x, n here is 5 trials, minus, again, we're clicking on the k value for x. Okay. And then I press enter and copy that down. And then I want to make sure to left align that to the left justified, so that I can see the front of the numbers without having to make my column huge. Or you can just make your column huge, that's fine too. But now you can see all the probabilities, and then just test out that that is the whole distribution. You can add up all of those and see that it adds up to 1. Okay, so seeing that all of these probabilities added together equals 1, that accounts for 100% of the possibilities. And also another way to tell or to have a sense of whether or not this worked right is to notice whether each of the individual probabilities are between 0 and 1, as they should be. Okay, so if you see any probabilities that are negative, or if you see any that are greater than 1, then something went wrong. And you'll notice that if I did the binom.dist in here and did the number of successes, then the number of trials 5, then the probability of success 0.718, and then false for cumulative. Okay, all of that should give me a probability between 0 and 1. And for some reason it's working here for me. I don't know why it's working here for me. It wasn't working a moment ago when I tested it. That's crazy. It's working. It's working now. I don't know how to explain why this is working. When I copy it down, yeah, it's working. So that, well, no, actually it's not. See, there we go. See, it's not working. No. It worked for that first one for whatever reason, and then it didn't work for the remaining ones. So yeah, I don't trust the binom.dist. Don't use it. Instead do what I showed you before. Okay, so that is how you get the probability of exact number of successes. Now, what do you do if you need to do one like another question where instead of the equal sign, it has the less than or equal sign, right? So if it's for less than or equal a certain number of successes, that's the cumulative probability. And normally what we would do is we would do binom.dist with the number of successes in that row, and then the number of trials, then the probability of success, and then we would say true for cumulative here, okay? And that would have worked in Excel, but it does not work here. It doesn't work here reliably, that's for sure. So don't use that either. So what do you do for cumulative? Well, cumulative just means that you're using the addition rule, right? So if you want to say, what's the probability that x is less than or equal to 0, right, in this row, that would be just the same probability for the exact number of successes. But then for this one, for this row, we're calculating the probability of 1 or fewer successes. So in other words, 1 success or no successes. So we're going to say binom dot, I'm sorry, we're not going to say binom.dist. That's what we're not going to say. Instead, we're going to say sum, and we're going to add up these two, right? So that's cumulative. I'm adding them up, right? Because 1 success or 0 successes would be favorable. And we learned in previous section about when you have the or in a probability problem, the word or means you can use the addition rule. You can add them together, okay? So we're just adding them. I'm using the sum function here just to make it a little faster as I go and get more and more of these to add. I don't want to do it all by hand. I'm going to use the sum function to make things move along a lot faster. Okay, so like that, and just keep doing this. For each one of these, it doesn't take too long. just adding them all up. And you know that the last one should be 1, right? Because it's going to add up all of the probabilities. And so, yeah, watch out for that. If it's not 1, something's off, right? So that is how you can construct a probability distribution or a cumulative probability distribution for a binomial random variable. It is also how you would answer questions, you know, using the binomial distribution in general, you know, so you're obviously not going to be able to use binom.dist for anything for less than 6. So you want to get to where you are able to do it by hand using this formula for exact probability. And then you would have to do it multiple times if you're going to do cumulative and then add them all together. So it really works out best to just go ahead and make your probability distribution. That way you can add together any of these depending on what the question is. For instance, if it was, what is the probability of exactly 3 successes, then the answer to that, for some reason, okay, there we go. The answer to that would be exactly 3 here. The probability that goes along, the exact probability that goes along with 3 successes. And then for another question, let's say, what is the probability of 3 or fewer successes, right? That would be this one, because that is in the same row as 3 successes, but it's the cumulative probability. Or if I didn't even have this column, all I would have to do is do the sum function and say, well, what's 3 or fewer? So let me add up all those probabilities together. 3 or 2 or 1 or 0, right? So not too hard to do that once you have your probability distribution set up. So the hardest part really is learning how to do this. And there is a way to make it a little bit easier if you first calculate your P and your Q. Oh, and let me give you one other scenario, one other example. What if it said, what is the probability of at least 2 successes, something like that? So then you would want to add together, because at least 2 means 2 or more. So I'm going to go add up these probabilities here. Okay, so as I was saying, this part is a little harder. So what would I recommend to make it a little easier? I would say first, let's make, as soon as you start your test, and this would be for test 2, go ahead and open up your blank spreadsheet and make your calculator. So you're going to make a place for N, a place for P, and a place for Q. Then you're going to put it in. So for this question, it was 5.781, and then, sorry, that was supposed to be there. And then Q would be 1 minus P, so I'm just going to calculate that there. Okay, so now I have my N, my P, and my Q. Now I'm going to set up my K row. So with 5 successes, I can have as few as 0 successes and as much as 5 successes out of 5 trials. And then I'm going to do my probability for X equals, so exact probability. And that's where I'm going to do the combine function and do N from this cell, right? But this is a reference that I want to use the same every time. So I'm going to put $signs on that to make it an absolute reference that does not shift when I copy the formula. And then I'm going to click on K, and I do want that to shift, so I will leave that as a relative reference. And I'm going to multiply that times P. Again, this cell needs to be the same for each row. This reference needs to stay the same. So I'm going to go ahead and put $signs in. And then I'm going to raise P to the power of the K in that row. leave that relative. I do want that to shift as I go down. Then I'm going to do q to the power of n minus x, or n minus k, rather. So I'll put that in parentheses, and I'll do the n, which is dollar signs. I want to make that reference stick to the n, and then minus the k in that row. Once I have done that, I'm just going to left justify these. Once I have done that, and I copy this down, I must have forgot to make something. I think it's this, right? No, this? Yeah, I forgot to make Q an absolute reference. You know, anything up here, the N, the P, and the Q, anytime you're referring to any of those cells, you want to make sure there's dollar signs on them. So my Q right there, which is in cell C2, column C, row 2, that one I also need dollar signs on. And I was able to tell I had made a mistake because what I was expecting to see were probabilities between 0 and 1, but having 0 on all three of these didn't make sense. I knew something happened when I copied the formula down. So now I'm going to try that again. I'm going to copy the formula down. And now that looks more reasonable. And then I can do my cumulative probability, x is less than or equal to k. And here I will just be doing my cumulative routine that I showed you before, adding up cumulatively all of these. Okay. All right. Oh, last one here, all of these. Okay. The last one for the cumulative column should always be 1. Also, all the probabilities in this column and in this column should be between 0 and 1. So those two checks help just catch mistakes. And once you've set this up, you could use this for multiple questions. And what I would do is go ahead and rename that binom calculator or something like that. Something where you know that you're going to come back to that to use that for multiple questions. The only thing you have to watch out for is when your n changes, you have to make sure that all your k values start at 0 but go all the way to whatever your n is. So sometimes you have to add on, let's say you did a problem after this one and the number of trials was 7 instead of 5, right? And then maybe the probability was different. The probability of success, let's say it was 0.341, right? So notice that everything recalculated, but you see that the last cell in the third column, the cumulative probability column, is not adding up to exactly 1. So something's wrong, right? Well, that's because I forgot that I needed my k values to go all the way to 7. So I would just need to add on, and then I can select both of these cells and copy them down at the same time. Oh, I'm sorry, I'm wrong about that. The cumulative one you have to do by hand. Do them by hand, but it's not too bad. They just add them up. Okay. And so that can be useful. And not every problem that is for lesson 6 will require a whole probability distribution, and certainly not always a cumulative probability distribution. In most cases, it might just be helpful to have the exact probability distribution, because you can always answer those questions as I showed you before. If it's a question that's asking you like P, that the probability that X is less than or equal to 4, you would be able to come in to if you just had these first two columns, you would be able to come in and go ahead and add those up like that using the sum function. You can also, let's say you have some kind of weird question where you need to add up, let's say it's the probability of several different possibilities, like X, let's say the probability of 2 or 5 or 7 successes, right? So that's an or situation. We can use the addition rule, but what we're going to want to do, since we can't select since they're not like where you can just select them like this, there's cells in between them. I'm going to put commas and just select each one. 2, the probability of 2, comma, the probability of 5, comma, the probability of 7. And so yeah. All right, so I may have given you more than you needed here. Hopefully this will help you while you're practicing. Make sure you're practicing. Take the practice test 2. The practice test for test 2, make sure you take it while on the LockDown browser so that you can use this spreadsheet. So if you are approved to take your tests using the LockDown browser and the video monitor, the webcam monitoring, instead of coming into the testing center, it's only because you have received special permission from me, and I should have made you a lockdown gateway for each of the practice tests and each of the actual tests that allow you to open up this spreadsheet app. And so because it does act a little different than Excel, it is especially important for you, if you're taking your tests on a lockdown browser, that you always practice using the lockdown browser spreadsheet. Okay, I'm going. Goodbye.